Okay, so we've just solved for joint A and joint D. We now have to still solve for, we're looking at our summary trust. We still need to get the last piece for our force trust calculation is member joint of BC. What is that? So I've got all of A, I've got all of D. I do have more information at B, and so we can look at and see what we've got. We've got a diagonal force there, but what I like is I'm dealing over here with just one unknown that we can come up with, and I have what makes C a little bit better is it's just like A, but I like C because we also have our interior angle. So we have that acute angle 29.7. I don't have that for B. You could solve for B if you wanted to. I'm going to go to C. I try to make it as easy as possible. So we're just going to go to C, and that's going to naturally get us everything solved out for B. So what we're going to do is we're going to create and solve for joint C. So I'm going to put this into a different color. I'll make this nice maroon for us. So we're going to put everything we know about joint C. So here is joint C. I know at joint C, I have a go up force of 150 pounds. 150 pounds. I know at joint C, I have 262.8, which is a go right, 262.8 pounds. And I do not have this member BC, which I have assumed is going this way. And I do not have that, which is going to be our vector BC. That's the piece that we need to solve for. In order to solve for that, we have to turn this into a right triangle. And I have my angle here. So I know that this angle is 29.7 degrees. So we know that that angle is 29.7 degrees. So what I'm going to do is we're going to turn this into our right triangle. Now you can Pythagorean theorem this, but I don't like to do the squares and square roots because you might get your negatives and your positives mixed up. So I stick to SOHCAHTOA. But there are certainly other ways that you could solve this. So I'm going to have to find this, which is, we're going to call this my vector. This is my BCX vector. And then we have here, this is going to be my BC, I'm sorry, this is my BCY vector, BCY vector. This is my BCX vector. And here's my right triangle. So I got my X and my Y backwards. So my Y is here. Now, here's what I know. Same with that opposite interior angle, 29.7. So I know that this angle is also 29.7. So if this angle here is 29.7 of what I made. So what we can do is we're going to solve for some information. So what we are trying to get here is I am going to, with this, what we're trying to solve for is I'm going to get my BCY. So I know that because we're statically determined, the sum of our forces in the Y direction have to equal 0. So I know that if I have 150 pounds, which is right here, plus, and this is going to be my BC in the Y direction, it has to equal to 0. Okay, so that means that my BCY has to equal negative 150 pounds. So I know that this is negative 150 pounds. So, which makes sense because it's, instead of being going up, it's going to be a go down. So this again is showing us that we assumed incorrectly and that this joint was in tension because it's a go down. So that means that once I've got a negative number, all the rest of my numbers have to be negative. Now, here's what I've got for you. So I can certainly solve this. There's lots of ways that we can do this. What I'm going to do is I'm going to find this. I need to find my BC. This is my hypotenuse. And what I've got here is I've got my opposite and my adjacent. And I don't know the adjacent either. I mean, I could figure it out if I sum my forces up and I did that, I could get my adjacent. But I'm going to stick to SOHCAHTOA. So I know that I have the sine. I'm going to have the sine over my opposite over my hypotenuse. So the sine of 29.7 is equal to my opposite, which is negative 150 pounds, over my hypotenuse, which is that BC vector. Okay, so now what I'm going to do with this is I'm going to isolate this. So I'm going to find this. So I'm going to make this my BC vector times the sine of 29.7 is equal to negative 150 pounds. Then I'm going to get this isolated. So my BC vector is equal to negative 150 pounds divided by the sine of 29.7 degrees. So we're going to put that into our calculator. Negative 150 degrees divided by the sine of 29.7 equals negative 302.7. Okay, so we're going to go back in here. So we know that BC is negative 302.7 pounds. And that makes sense because what that is telling us is this is negative. This is our negative. Our hypotenuse has to be the longest side. We know that this would be 262.8. So that makes sense. So 302.7. So we are going to go back over to our summary truss. And we're going to put in the last little bit of information we have. And we know that was a negative. So that is going to show us that it was going up and going up and to the left. So let me get the right color here. So this was correct in saying that this is going to be in compression of, and what did we say that was? It was, I didn't write it down. It was negative 302.7. Okay. So that is going to be in compression, 302.7 pounds. And that right there is our summary truss calculation for the forces. So we are showing that these two members are in compression, or these three members are in compression. This member is in tension. And so we have got all of our forces listed on it, and everything is equaled out to 0. This is statically determinate. We have solved for that truss calculation. Congratulations.